Question 5. Okay. So, modern pennies are composed of zinc and coated with copper. After making several scratches in the penny, the mass of the penny is determined to be 2.482 grams. And this is after scratches, okay? So I guess they just kept scratching away and then waited. But we just have this number for now, and that will come into play later, okay? And now they also ask, the student puts a penny into hydrochloric acid, so HCl, via single replacement reaction. So, in a sense, what's happening is that it's replacing something, and just like one of these is being replaced, and it looks like what is being replaced is actually the hydrogen, and it says only the zinc reacts with this. So there's zinc and copper, okay, but only the zinc reacts with it. So what we have is this formula: zinc solid plus HCl, and they said it's a single replacement, so that means we got zinc Cl, and because it's zinc, actually it's going to be zinc Cl2, because most of the forms of zinc is zinc 2, okay, and plus H2. So that is what we have there, okay, aqueous and hydrogen gas, as they said, okay, and the hydrogen is collected at 25 degrees Celsius over water. That is important because now we have to factor in the vapor pressure because we're collecting gas over water. So that does play into this question here. The collected total gas is 0.899 liters, and the pressure measured here is 7.91 millimeters of mercury. And now, with all this information, they want to find out what is the percent of zinc. Okay? And we're assuming here that all of the zinc dissolved. So they gave us a mass earlier, this 2.482. We can just assume that to be the total mass of the penny. And now they're asking us how much of that penny is zinc. So we do need the mass of zinc that was formed from this equation based on what they've given us. So first thing that I would do actually is see how the vapor pressure factors in. So actually they do give us a pressure here, and the vapor pressure of water, you have to subtract it out of this. So we have the 791 millimeters of mercury minus, so water's vapor pressure, as I've written down here, is 23.8 millimeters of mercury. So the true pressure of just a hydrogen gas, okay, because they give us a total pressure, that's why it's important. They didn't say hydrogen pressure, they said total pressure. That's why you have to factor this in. So when you subtract it, just the hydrogen pressure is 767.2 millimeters of mercury. So now we have the pressure of just the hydrogen gas. So now that we've done that, I like to convert it over to atmospheric pressure because it helps me use a simpler R constant. So with that, this turns into, when I do the conversion, 1.009 ATM. Okay, and you can find the conversion online or even in your textbook. Just that way you have it, and it's important that you account for what type of pressure you're using, like units, because that does affect the R value. Okay, so with that, when I'm solving for moles, I need to use the equation PV, pressure volume, is equal to moles times that R constant, the gas constant, and temperature in Kelvin. So we're solving for moles here, so we can get the mass. So we have N is equal to PV over RT. Okay, So with that, we have 1.009 ATM times the volume being 0.899 liters. Okay, and remember, this is now, we don't need to worry about the vapor pressure of water. We just know that the gas occupied 0.899 liters. We don't need to factor in water because the total pressure only affects the vapor pressure part. So with that, we have that pressure and volume. Okay, and now we need the gas constant using the ATM units, and that is 0.08206 liters times ATM per mole times Kelvin. Okay, and that is times, because you still need to factor in the temperature, and they do give us 25 degrees over water, and 25 degrees Celsius, okay, plus 273.15 is how you translate to Kelvin. So that's 298.15 Kelvin. Okay, and so you just add that here. Okay, alright, and just cancel some units. There, ATM, liter. All that's left is mole in the denominator of a denominator, which puts it in the numerator. So in total, we get N is equal to 3.71 times 10 to the negative 2 moles of zinc. That's how much zinc was produced based on that equation. Okay, no, whoops, sorry, I think I skipped ahead. 3.71 times 10 to the negative 2 moles of hydrogen gas. There we go. Okay, that should be it. And now we have to make sure that we transfer accordingly. It is a 1-to-1 ratio, as you noticed. 1 hydrogen gas, 1 zinc. So with that, actually, based on the fact that we have this many moles hydrogen gas, we need the same amount of moles for zinc. So that means actually we do have 3.71 times 10 to the negative 2 moles of zinc as well. And that is what we have for moles. Then we use our periodic table to find out how many grams that is. So that would be 3.71 times 10 to the negative 2 moles times 65.38 grams per mole. Units are canceled out. Okay, and total we get 2.43 grams of zinc. Okay, so now we figured out how much zinc was there initially, and using that and the initial number we got in the beginning, we can find out how much of it is composed of zinc. Of zinc. So percentage would be 2.43 grams divided by the total of 2.482 grams times 100. So the penny, or was it nickel? Yep, the penny was actually composed of 97.71% zinc. Okay, so just a quick run through. We found out the true atmospheric pressure of just hydrogen gas by subtracting the vapor pressure. Then we use that to find the moles of hydrogen, and then use that to find the moles of zinc, and then we use that to find the grams of zinc, and then we use that to find the percentage. Okay, so let's see what they did. Yep, they accounted for the vapor pressure of water. They use a different number, but it still ends up with a similar mole count because they use a different units. So they use a different R constant because they did it in pascals and kilopascals. So with that, they still do get the 3.71 moles times 10 to the negative 2 moles, and then in the end we still end up with 2.4 grams of zinc, and that means 97.7. They did get 97.8, but that's just depending on how you round it. I like keeping my numbers as full as possible till the end, hence I got the 97.71. But overall, this is correct. Okay. And now let's move on to question 6.